right, so we are going to talk about similar three-dimensional figures now. So we've just, well, for a long time talked about similar 3D figures and how we have to set up proportions to find missing sides. But now we're talking about changing between, I call them the worlds. So in plane world, that's what we've been playing with. We find our scale factor, we set up a proportion, and we proceed from there. But now we're going to look at what would happen if we're given one surface area in one dimension and have to switch to a different dimension. So the thing that I always do is I make this little kind of, I don't know what to call it. Um, it's not a mnemonic device, but it helps me remember. So this is how you change between worlds. I guess maybe it would be better to put a double arrow. So surface area world, plane world, and volume world. What's super important to know to begin with is that uh, all fractions, all scale factors must be simplified before you move on. So we're going to simplify the ratios before proceeding. Now on this page, they're already simplified, so I'm not going to do that step, but on the next page I will. All right, plane world is anything that does not say surface area and does not say volume, so length, perimeter, height, radius, but that's not all. As long as it doesn't say surface area and it doesn't say volume, you're in plane world. All right, it's one dimension, two dimensions, three dimensions. That squared, well, it stands for two dimensions, also stands for squared and cubed. So if we wanted to move from plane world over to surface area world, all we need to do is square the numbers that we were given. So the scale factor in surface area world would be 9/64. And opposite, if we want to go to volume world, then we need to cube them. And our new scale factor would be 27, oops, that should be an 8, over, oh goodness, I never can remember this one until I do this unit, 512. So that's if you're given plane world. But if you start in surface area world, you need to think about what that means. 16 and 49 had already been squared. So think about what the opposite of squared is. Square root. So we're going to take the square root of these numbers to go backwards to plane world. 4/7. You always have to pass through plane world to switch between surface area and volume. You can see that up here also. All right, so now we're going to go this way. We're going to take our 4 and our 7 and we're going to cube them to move to volume. So that's 64 and I think it's 343. Yes. All right, so this is the movement. Now, how do you think you're going to get from volume, where it had already been cubed, back to plane? So these had already been cubed, so we want to take the cube root. And the cube root of 8 is 2, and the cube root of 27 is 3. And again, move over to surface area world, where the numbers need to be squared. All right, so that's the process with the numbers. Now I'm going to show you what it looks like in geometry. All right, this one goes through a couple things. I'm just going to do kind of every other odd or every odd problem maybe to give you the gist without overburdening you with listening to my annoying voice. Here we want to figure out if they're similar. And remember, to figure out if they're similar, the sides have to be proportional. Just like in similar one-dimensional things. All right, so the sides are proportional, or the measurements are proportional. So let's check. I'm going to do 14, the radius of the big one, over the radius of the small one, 4. And I guess I'll color code that just in case that helps any of you. And then we have the height to compare to the height. Since we have the big one on top here, we're going to put the big one on top there and the small one. So let's check them and see. We have 14 divided by 4 and 20 divided by 6. Are these similar? No, because these are not the same. If they were the same, so I guess let's do number 2 just to show you, because I'm assuming this one will be. We're going to compare corresponding parts. So we have 10 over 15. We have 28 over 42. And I can just look at these and guess only because I know the intention of the problems and these are oriented the same. 26 over 39. Let's check those. All right, since these are all the same, yes, these are similar. But it tells us to find the scale factor. Now, all of these are essentially the scale factor, but we need them in simplified form. In this calculator, all you do is you press math and then go to fraction, and it will tell you the scale factor is 2/3. It's the simplified version. On Desmos, after you type in one of these fractions, like 26 over 39, there's a little button on the left-hand side that looks like this. If you click that, it will change to a fraction. All right, number 3. These are similar. What is the scale factor, surface area ratio, and volume ratio? So to do these, you have to look at what they're giving you. Here, it's giving me a one-dimensional thing. This is the plane scale factor. It's just giving me the slant height. So we're going to do 20 over 5 is the ratio, and we want to simplify that to get the scale factor, is 4. Now I'm going to write it as 4 over 1. That is the simplified version. All right, now we want to find the surface area, and remember to find the surface area, use square. So 4 squared is 16, 1 squared is 1. Volume, you go back to the scale factor and you cube it. 4 cubed is 64, 1 cubed is 1. And I am going to do number 4, but I promise I won't do all of them, just to show you how it would work when we fill in a different spot. For this one, you can see we're actually given volume. So we're going to make a scale factor out of the volume, or a ratio. We're going to simplify it, but we're going to put it down here because we were talking about volume to begin with. So simplify, 250 divided by 686 is a yucky looking decimal, but I'm going to press math, fraction, enter. 125 over 343. And as you do this, you will recognize those numbers. Now remember, it goes surface area, plane, volume. So if we want to go from volume, we have to pass through plane first. So we need to take the cube root of 125, which is 5, and the cube root of 743, which is 7. Now we can move ahead and square 25 over 49. So we're going this way and then this way. It's important to pass through plane world first. All right, I hope you get the gist so far. Let's keep trucking. Number 5. Prism A is similar to prism B. The ratio of the surface area, so this is, I'm just going to model how I do it, okay? The ratio of the surface area, so we're going from surface area world, of prism A to prism B is 81 over 4. And this is the format I write it in. We want to find the volume. And remember, we cannot go directly from surface area to volume. So we're going to write this at the top. Check to make sure that you're simplified, although since it gave us scale factor, it is. And let's move through the worlds. Surface area to plane, square root, 9 over 2. Now cube. You know that's 8. 9 cubed is 729. So the surface area scale, or volume scale factor, is 729 to 8. Okay, let's look at another. Cone A has a diameter of 10 inches. Bing, bing. In my head, we're starting in plane world. Okay, diameter is a one-dimensional thing. And the diameter is 10 to 50. So I'm going to write that here under plane. We want to go to volume. So we're going from plane to volume. Now here's where that simplifying matters. 10 divided by 50 is 1/5. So write that underneath, just like this. Now we move over to volume. How do you get from plane to volume? Cube. So 1 over 125 is the answer. That is the volume ratio of A to B. All right, let's do number 9. If the prisms below are similar, what is the volume ratio of the larger prism to the smaller one? So this is important to make sure we get it in the right way. We are given a measurement, one dimension. We're given the height. So we're starting in plane world, and it tells us we want to go to volume. So similar to the last one we did. It says larger to smaller, so I'm going to put the 18 over the 15. Simplify. 1.2 math fraction, 6 over 5. So that should go right there. And we want to move over. We know 5 cubed is 125 and 6 cubed is 216. So the volume ratio is 216 to 125. Okay, now here's where we go one step harder, right here. Now we're going to do this process, but we're also going to actually give the new volume. So in order to do this, I highly recommend you copy my formatting of these problems. We're going to do two different things. The ratio of the heights is plane world, of two similar cylinders is 1/3. If the volume, so we're going to volume, of the similar cylinder is 67 centimeters cubed, then you will be going to volume world. So in order to go from plane world to volume world, we cube. 1 cubed is 1, 3 cubed is 27. Now, we need to take this over to the other side and set up a proportion. Okay, it says the volume of the smaller cylinder is 67. Since it's the smaller one and the smaller number is on top, that's 67 centimeters cubed goes on top. And we want to find the volume of the larger one. Now it's this normal proportion. We're going to solve by cross multiplying. 67 times 27 is 1,809 equals X. So the volume of the larger cylinder is 1,809 centimeters cubed. All right, so do you see the process? We're going from plane world to volume world, moving up our scale factor. This is super important. And then setting up a proportion. Let's do it again. Pyramid A and pyramid B are similar. The volume, so we're starting in volume, of pyramid A is 448 inches cubed, and the volume of B is 189 inches cubed. We are going from here to height. It says height, so we're going to plane world. Now remember, in order to go backwards, you need to simplify your fraction first. 64 over 27. And we want to go to plane world. In volume world, they were already cubed. So we want the cube root of 64, which is 4, and the cube root of 27, which is 3. We're going to take that and set up a new proportion. Now, this one's a little bit weird because it gave us A and B, not big and small. So we're going to kind of go back and look. it says volume of A is 448. So we have A on top and B on the bottom. So if it gives us the height of pyramid B, that's going to need to go on the bottom, and on the top is what we're looking for. Cross multiply. 3x equals 156. Divide by 3, 52. So the height of pyramid A is 52 inches. Let's look at one more together. I hope that this process is making sense. Solid A and B are similar. The surface area, so we're starting in surface area, of A is 675. And I'm going to put A on top here just to keep track of it. And the surface area of solid B is 432. If the volume, okay, so we're going from surface area to volume. So we have to pass through plane to get to volume. I would highly recommend you do this exactly how I'm doing it. It will make it much easier for you to remember. To go from surface area to volume, you have to pass through plane. But first, we need to simplify our fraction. So 25 over 16. And now start moving. To go from surface area to plane, we square root. And from plane to volume, we cube. That's going to come up over here. And we're going to set up our proportion. The volume of solid B is 960, and we had B on the bottom, so 960 goes on the bottom. Find the volume of solid A and cross multiply. 64x equals 120,000. Divide by 64. So x equals 1,875 meters cubed. Okay, that's it. That's all you really have to do. I hope that makes sense. Try the practice, and good luck.